Direct variation. Now, direct variation uses the equation y equals kx, where k is the constant of variation. Now, an example in real life that's a direct variation is if you have a part-time job or a job. The more hours you work, the more money you get paid. The less hours you work, the less money you get paid. But what's always constant is how much you get paid per hour, your rate, until you get a raise, and then it might change. Otherwise, the constant is how much you get paid per hour. How many hours you work changes, and thus how much money you make. But one thing is always certain. If you don't show up to work, you won't get paid. So you get $0 for 0 hours of work. And that's why both of these graphs go through 0, 0. All direct variation graphs go through 0, 0. Because if you work 0 hours, you will get paid $0. So please remember that all direct variation graphs go through 0, 0. Now let's take a look at what the constants are and the slopes of these two equations. So k is the constant of variation. You can see it here as the number 2. Now, if I try to figure out the slope, I can go up from 0, 0, 2 places, and over 1 place. So the slope is 2 over 1. Hopefully you notice that 2 and 2 over 1 are the same number. So in the first instance, the slope and the k are the same. Let's see about in the other one over here. So k is the number in front of x, so it's -4. Now if I do rise over run, I'm going to go down 4 and over 1. So my slope is -4 over 1. And again, the slope and the constant of variation match. So please note that slope and the constant of variation are the same. If you remember our formula from a previous lesson, mx plus b, you'll notice that slope and k are in the same location. That means they're the same. But you notice there's no plus b in direct variation. That goes back to no work, no pay. You have a plus 0 because every equation goes through 0. That's why it's plus 0 and not plus b. All right, next. So here we're going to make a graph. Now, remember, all direct variation graphs go through, that's right, 0. So every direct variation graph starts at 0. Now, the slope tells us to go down 2 and over 3. Put our second dot and then draw our line. Remember, always start at 0, 0 with a direct variation graph. Now, suppose we have a word problem here. It says y varies directly as x, and y is 9 when x is -3. Write a direct variation equation. So if we use our direct variation formula, y equals kx, you'll notice there's 3 letters. I was given 2 numbers. If I have 3 letters and 2 numbers, I can plug those 2 in and solve for the missing one. So 9 goes in for y, and -3 goes in for x. So if you solve for k by dividing by -3, you'll get k equals -3. Now that's not the answer that the question asked for. It asked for an equation. So I'm going to fill in y equals -3x is my direct variation equation. So remember, a direct variation equation includes a number 4k. It leaves the x and y, and then remember there's no plus b at the end because it's 0. Now part B here says use that equation to find x when y is 15. So if you're using that equation, y equals -3x, and you make the y into a 15, you're only left with one number to solve for. So you divide by -3, and you figure out that x equals -5. And that's how you solve for x, and that is a 5. All right, next. So here's one just like the last one, but without all the words. So solve first for k, and then use that k and solve for x. So 15 goes in for y, 12 for x. Divide by 12, and if you'd like to use a fraction, that's 1, or a decimal, that's 1.25, or a reduced fraction is 5/4. It doesn't make a difference what the k is unless you were trying to graph it. But since I'm not graphing it, I'm going to use the 1.25. Now I'm going to substitute in my 32, because that is what x is. I multiply those together, and I'll find out that y equals 40. Now let's take a look at the other type of variation, inverse variation. Now an inverse variation uses another formula, which is y equals k over x, or xy equals k. Basically, instead of with direct, as one number goes up, so does the other, or as x increases, so does y, or as x decreases, so does y. Here, as one goes up, the other goes down. For example, if you're trying to drive somewhere, the faster you drive, the less time it takes you to get there. So if you're going to visit a friend of yours, unless they've moved, the distance from your house to theirs is constant. But if you ride in a car versus pedal on a bike, one method is faster than the other and thus takes less time. More speed, less time. See, as one goes up, the other goes down. Now, looking at these charts and equations, how do we tell if one of them is direct or inverse? Well, the way we could tell if something is inverse is we look to see, do they multiply together and equal the same number? If you take table A and multiply across, every time you multiply, you get 16. So that tells me that x times y equals 16. Since the two numbers multiply and equal the same thing, that is an inverse variation. That looks just like the formula above. However, if you multiply by the same number to equal the y, you notice 3 times 1 is 3, 3 times 3 is 9. Every time I do this, I take my x and I multiply it by 3, and that equals y. That is a straight up direct variation formula. Now the other ones, they've been kind of rearranged and messed with to see if you can try to hide what they are. But let me show you something. First, I'll take C if you're not sure what it is yet. I'm going to flip it around. And the property that says I can flip it around again is symmetric. Now I'm going to get rid of that 2 that's in front. So I'll divide by it. And remember, there was no number in front of x, so I'll put a 1 there. So that makes 1/2 x. With the y first and the x on the other side, this is a direct variation equation. Now with the d here, you notice there's a 2 in front of my xy. What if I divide by that? Now there's no 2 there anymore. And 10 divided by 2 is 5. Now this looks exactly like the formula for inverse variation. So this is how you should figure out if a formula or a table is a direct or inverse variation. Here's 6 that you should try to pause now and solve these 6 to figure out, are they direct or are they inverse? Okay, so if you notice, every time you multiply, you get 10. And if you multiply and get the same number, that's inverse. This one, it doesn't really multiply by the same number to go down. Instead, it's dividing. You divide by 2. Well, dividing by 2 is not really a direct variation. So what's the multiply of divide by 2? If you said multiply by 1/2, that's correct. Multiplying by 1/2 is the same as dividing by 2. So if I multiply by the same number, that's direct. And C, looks like I'm multiplying and getting 12 each time. So that's another inverse variation. If D doesn't look familiar, try some symmetric property on it. Clear the y's first. This is straight up y equals kx, direct. E looks a lot like D on the last slide, so I'm going to divide by -2. xy equals -10. That certainly looks inverse to me. I got x and y. I think they're on the wrong side, so I'm going to do a little symmetric property here. Now, if you're not sure what to do with 0.5, might I suggest changing it into a fraction? If that still doesn't help, how would you get rid of a 2, a fraction, 1/2 in front of your y? You would multiply both sides by 2. And now you've got y equals 2x. And that, again, is direct. Lastly, let's take a look at some word problems for inverse. So this one says to write an equation that's an inverse variation equation from the information y is 5, x is 3. So remember, my formula is y equals kx. 5 goes in for y, 3 goes in for x. 3 times 5 is 15, so k is 15. Now, if it asked me for the constant, I'd be done. But it asked me for an equation. So it's not y equals kx, it's xy equals k. And what's k? 15. All right, and lastly, we're going to write the equation in inverse variation and then solve for the missing number. So if you'd like to pause and do these. Remember, x times y equals k, and then x times y equals k. So 12 is x, 3 is y. Multiply those together and you get 36. So I'm going to use that 36 over here. My x is x and my y is 4. If I divide by 4, I will get x equals 9. Same setup with the other problem down here. xy equals k, xy equals k. X for 12, 5 for y. 12 times 5 is 60. Move that 60 over here. X is 4 this time. Y is still y. Divide by 4. And y equals 15. And that is direct and inverse variation.